mathematician. Read it to me and then I'll try to describe what's going to happen.
Yep. So suppose f is a polynomial function written in standard form.
Hang on now. So this is it right here. Not factor, but standard form. We'll apply Descartes' rule to this one. Okay.
And it says part A says the number of positive real zeros of f either equals the number of variations in the sign of the non-zero coefficients of f of x, or else equals that number less than an even integer.
Now, can you imagine reading that yourself in a math textbook and have no professor to describe to you, break it down and show you what it really means? You read. That's what happens in grad school. They just give you a book to you. Then you got a quiz the next day. And you read that. And you try to make some sense of that. Okay, that is a crazy statement. Read it to me one more time.
Yep.
Slowly, okay.
Yep. So the number of positive real zeros.
Okay, hang on now. Of the of the 5 zeros I'm expecting here, he's telling me something that maybe I will know how many of the 5 will be positive, even before I find them. This is Descartes' rule, so I'm expecting 5 zeros. How many of those 5 will be positive? Will 2 of the 5 be positive and the others negative? 3 of the 5 be positive and the others maybe imaginary? Thanks for checking. Read more.
So number of positive real zeros of f either equals the number of variations in the sign of the non-zero coefficients.
Stop right there. So this says now jump right to your polynomial function and go from left to right. And if you see a sign change from one term to the next, this is where Descartes' rule is going to help me. Is there a sign change? Look at the coefficients. The coefficient on the first term is understood to be a positive 1. Does it change to a negative, in fact, -7, when I reach term 2?
Yeah.
Is that a sign change? I went from a positive first term to a negative. Put a little check. Now I go from this term to this. I'm going from a -7 to a positive 19. Is that a sign change?
Yes.
-7 to a positive 19. Then I go from 19 to a -37. Positive 19 to a -37. Sign change. A -37 to a positive 60.
Sign change.
Sign change. Changes from -37 to a positive 60. Oh, scare me. And from 60x to a -36, 60 to a -36, a sign change. That tells me, from what I have on the board here, how many sign changes? 1, 2, 3, 4, 5. Was it 5? Yeah, 5. That tells me at this point, all 5 zeros, Professor, may be positive. And therefore you need not test negative, a negative. There are no negative zeros maybe. It says right now at this point that all 5 may be 0. But he's going to add something to this. Now, add something to it.
Yeah. So it says either equals the number of variations in the sign of the non-zero coefficients of f of x, or else equals that number less an even integer.
Okay. Now, in that strange way phrase, guys, it says less this by an even integer. Let's use the smallest even integer I can work with, which is 2. I know 2, 4, 6, 8, those are even. So let's try 2, which says less than. That says, besides this possibility, you may have 5 positive real zeros. All 5, when we finally find them, which I haven't done yet, all 5 may be positive. Or he says, hold on, Professor, it may be that number 5, and you have to subtract from it. I'm using 2 for my even number they're talking about here. So what's 5 subtract 2? So 3 could be positive. We have not discovered what they are yet. And then, if you can, that possibility reduce down by 2 again. So what's 3 subtract 2? 1. There might be only 1 positive, real, 0. I don't know yet. These are the possibilities of how many of the 5 may be positive. All 5 could be. Only 3 and the other 2 something else, imaginary or negative. And only 1 positive and the other 4 negative or imaginaries in there. Those are the possibilities. Wonder why they're saying, I think it's good, if we reduce it down by two, he just says an even number. Wonder why it might be wise to go ahead and reduce it down by two. What else may be involved that might throw the real zeros off? Some of the zeros may be what? Well, something else.
Oh, imagine.
It may be imaginary. Therefore, it'll be non-real. And this one would not even apply. So he's saying maybe subtract that out. This is only for real zeros. So don't worry about those imaginaries that come in pairs, okay? Now, can you now describe for us, saw a hand go up. There you go, was that you?
Yeah.
Yeah.
So just again clarifying, for Descartes' rule of signs, if there is a sign change all the way through and from 5 to positive real zeros, you just subtract 2,
Subtract two until you can't subtract two again.
and then that's gonna give us our positive.
That will be. And as we find the zeros, which I have not found yet, guys, I have not found these 5 zeros. When I finally finish up, this is gonna work. It's gonna be one of these possibilities. Now, Jonathan, how about the number of negative real zeros?
So yeah, part B says the number of negative real zeros of f either equals the number of variations in the sign of the non-zero coefficients of f of negative x.
Oh, thank goodness you got me here. Thank goodness you got me here. So say now, go back to your function and find p of a negative x. This is going to help me to determine how many negative zeros I may end up with. Let me do that first though. So I'm going to go through my original function he gave me. You guys help me out. You're replacing x with a negative x. If I do it here, a negative x raised to the 5th. Result will be negative x to the 5th. Let me do this. What I would like to happen, I don't know what's going to happen here or not. I would like to see no sign changes on this, but we'll see. So this is a negative x to the 5th. Now the second term, you're going to replace x by negative x, which is being raised to the 4th, which turns into a positive. That times the negative 7 up front. Negative, all together. Here I'm replacing x by negative x, cube it, get negative. Times 19, still negative. Okay. That's cute. Down here, replace x by negative x squared, that's positive. Times the negative 37, negative. 60x, replace x by negative. 60 times a negative, positive, 60 times a negative will give me a negative. 60x, and of course on the ends, negative. Isn't that cute? By the way, guys, this does not always happen. It did here. Are there any sign changes as I go from one term to the next one on this one?
No.
That says, okay, professor, you've lucked out here. Out of those 5 zeros, when you start searching and try to find them, none are negative. Don't test a negative number. A negative number is not going to be a 0. All 5 must be either positive, and then the others, a possibility could be some imaginaries. This, I think, applies only for real. So for right now, I know for sure there are no real negative real zeros for this function. So do not expect a negative real number to come out as one of those 5 zeros. Leo,
And it's just because of the sign change.
that's it. Here you go, just sign changes. Okay? Now, was that Descartes' rule, was that finished?
Yeah, and then it says, or else equals that number less than.
Okay, thank goodness I have none here to begin with, so I need not reduce it down like I did the positives. So this part here is not needed, because I have nothing to work with. I got 0. Yes,
Could you just repeat that again?
what's it now?
Could you repeat what you said for the negatives? I don't know. How did you get to 0?
Oh, the possibilities.
Yeah.
There'll be none here.
Why?
There's no sign change. So if there's no sign change, guys, automatically it says you have none. Therefore, you don't subtract 2, subtract 2, subtract 2. You have none to begin with. Initially, you have none. If you do have something, like up here I had a 5, then you have to reduce it down, and get other possibilities for the number of zeros. Here, I don't know where those negative zeros, there are none.
So it's
Eric.
only if there's no sign change on the even exponents, right?
No, go from term to term to term to term and look at the sign changes on all the terms, not just positive, or even or odd. It's for all of them.
So if it just goes, so for instance, if it was vice versa, if it was all positive throughout, there would
Wouldn't there
be,
be 5 negative real zeros?
Oh, you mean here?
yeah, let's just say.
If this were positive all the way through, even that, let's say that's positive. Jonathan, class, if all these had been positive, guess what that tells me? There's no sign change, and therefore, in this case, there'd be what? No positive real
Zero
zeros.
positive real zeros.
It's just the sign change is taking place, which we're going to get accustomed to. Now, keep in mind, guys, I have not found those 5 zeros yet. But right now, by Descartes' rule, I know none of the 5 will be negative. None of the 5 will be negative real numbers. Okay. Jonathan,
Yeah.
please help me. What does it say next?
Still on part B, or you wanna talk about the?
Yeah, just what followed right directly after
Oh,
that?
so the example says discuss the real zeros of f of x
Okay, hang on. F of x.
equals 3x to the 7th.
Now, Eric, I maybe have an interesting question here. 3x to the 7th?
Minus 4x to the 4th,
Okay,
plus 3x to the 3rd,
okay.
plus 2x squared,
Oh, geez.
minus x, minus 3.
Now, guys, I'm not gonna try to find the zeros. He just asked me to describe them. And how many zeros am I expecting if Jonathan, make sure I copy that down correctly.
Yeah, 3x.
I'm expecting 7 zeros. So out of 7, are there 4 positive and 3 negative? I don't know. 2 negative, 5 positive?
That's fine.
One positive, and the other 6 imaginary? I don't know yet. I haven't found them. But I do know this. The sign changes right now from term to term. Is there a sign change there?
Yeah.
From the second term, from a -4 to a +3, sign change. Here, look at that. No. No sign change on that one. From this term to this one, is there a sign change? Yes. And on the end, no. So how many sign changes did I get altogether? 3. So that says at this point, of those 7 zeros you're expecting, guys, it says I'm gonna have a possibility of 3 positive real zeros. Or, what's the or case? You reduce that down, if you can, by what number? 2. And then we say now, you may have just 1 of the 7 to be this. We're not gonna try to find these on this one.
So Professor Ramsey is like, I guess like Descartes' rule of signs just kind of just like a scanner.
It scans it
It
for you.
just scans it for you so you can determine.
And before you jump in and actually find them, which we have not found any of the answers for these up here yet, it just tells you how many positives, how many negatives, and what's left over, imaginaries, you may get. Okay. Now, let me go ahead and find the number of negative zeros. Now, guys, this is positive. To find the number of negative zeros, he's telling me now find f of a negative x. It's a little routine. So go through and replace all these x's by negative. And Eric, let's see if this will help you out here. Replace all the x's by negative. If I do the first term, I'm going to end up with a -3x to the 7th. Second term, we've got to be careful. Replace x with a negative x raises to the 4th, that stays positive. But times the -4, negative. Put a negative here, oh my goodness. Okay, negative x cubed times 3 would be a -3x cubed. It's looking too much like the one I did over here. Here, is there going to be a positive 2x squared? It does, no change there. Replace x with a negative x here, I got a negative already, replace x with a negative x, turns into a positive, and then finally -3. You guys agree? Okay, now let's count the number of sign changes here. From here to here, no sign change. From the second to the third term, interesting, no sign change. From the third to the 4th, sign change. From the, I guess, 1, 2, 3, 4th to the 5th, no sign change. And finally, what? Sign change here from x to a -3, another sign change.
Why did we not consider that on the top one for positive from X to 3 then? I guess because it didn't change, but.
It didn't change
Okay, I see.
up here. I'm looking for sign changes. I'll try to count some of the sign changes. Guys, did I do the number of sign changes correctly on this one down here? If so, that says I have 2 sign changes. Now, what does that tell me? That tells me if we're going to find these, of the 7 zeros, I could expect how many to be negative? Expect 2. Okay, so on the side here, guys, I can have 2 since I got 2 sign changes. 2 of the 7 can be negative. And I should say negative real. 0. And the possibility though is also
0.
0. Always take that number and reduce it down by 2 if you can. That's what Descartes says do. I may have none. And I can't reduce it down any further. And those are the possible zeros. Woo! Now we're going to have to find them over here. Okay. Now this was a separate problem, guys, on your handout. I'm going to get back to the one where we're actually going to find them. So I'm looking at this right here. And did we decide down here, Jonathan, remind me, on this one, there was no sign change period on this one.
Yeah, that was.
And therefore that says you don't have to worry about this, because that just says there are going to be no
Sign change.
negative real zeros. None. Woo. Leo, how many zeros am I expecting? Because we're actually going to find these. I'm expecting how many on this thing? 5. All 5 could be positive. We haven't gotten yet. Or Descartes says no, maybe only 3 are positive. That would leave the other 2 to be what? Imaginary. None are going to be negative. Or only 1 is positive and the other 4 must be imaginary. There are no negatives here. Okay, guys, we got 5. There's a what? We got 5. Up here. I'd love to be able to group this. I'll be ahead of time to say myself sometime. I'd love to group this like I did one earlier today. Group it and try to find the zeros. And the grouping's not gonna work here on this one. If this does not wake you up as a student, you say, Professor, are you kidding? We're gonna find all 5 zeros? Yes, we're gonna find all 5. We're gonna find all 5 zeros for that crazy thing up there. Okay, now we go back to my middle school problem. That kid knew, hang on guys, hang on, where am I here? Trying to think what I'm doing here. Okay, good, beautiful. He was given this. Let me go back to what he had in middle school. This is quadratic. Let me go back. Leo, if I take this simple quadratic, which all of us could do, and I apply Descartes' rule of signs, even on this one, from here to here is 1 sign change. And from the second term to the third term, no sign change. What does that tell you quickly about the number of positive zeros of the 2 zeros I'm expecting? 1's gonna be positive. 1's gonna be positive because I have 1 sign change. Now we'll find how many will be negative, Professor? And this one, I think the other one's gonna be negative.
Also 1.
Yeah, that's 1. Okay, you can find P with negative X. Now it all comes down to, so I can get back to my problem here, it all comes down to, I can't factor like this, like we do here, on that thing there, we're not factoring. But yet we're gonna find the answers. Something else to point out, what was I gonna point out? Oh, yeah. His method was to list all the factors of a negative 10, which we said looked like this, 1 times 10, negative 1 times a negative 10, negative 1 times a positive 10. The numbers fixed up here. Okay, guys, 1 times 10, no, negative 10. Come on, get that act together here. He had a negative out of this. Middle school kid had a negative 10 on the end. Let's make sure I break this up here so you guys can see it. I gotta list all the factors of negative 10. Easy done, I'm just making it harder. Okay, negative 10, 1 and a negative 10. Negative 1, positive 10. 2, negative 5. A negative 2, positive 5. Are those the factors of negative 10? For the middle school problem. Here, hang on a second. And he went through and tested each one of those 6. Do I have 6 or 8? 8, 2, 4, 6, 8. He's got 8 possibilities, and he was patient enough to plug them in, plug them in, plug them in. That's what he was doing on the other problem. That worked. And it didn't work this time. And then you guys told me right before the break, the reason it's not working this time, this little plugging in numbers, is what? The leading coefficient is not a 1. It's a 6, it's threw him off. So what Johnson's going to read for us here shortly though, there is a method, and I'll point this out to the kid. There is a method. You can go ahead and list those factors like he was doing. Boy, I think that's a good way to do this. That constant term, he had 1, negative 10, negative 1, positive 10, 2, negative 5, negative 2, positive 5. Notice I threw a bar there, we'll place something underneath it. What do you think the kid could have done? He needs more numbers to list, and where are those other numbers going to come from? That's why I was out to find the 0. He's got all these are the factors of that constant term on the end. That's what he was doing. But now since this is on a 1, I got a 6. Guess what I gotta do to modify this? I've got to list now the factors of 6. Where? Underneath these. Like 1, 6. Negative 1, negative 6. 2, 3. Negative 2, negative 3. Okay, so on top are all the factors of that constant term, like he was doing, and we're going to read all this for us here shortly. And on the bottom, to modify this little method he had, you've got to now list the factors of that 6 out front, which messed us up. You've got to list all the factors. Now guys, I did the factoring here before. We know the answers are these 2. Please tell me, a negative 2/3, we got by factoring. Is there a negative 2/3 in there?
Yeah.
The other answer came out, we would have done it by factoring, we got 5 halves. Is there a 5 halves in there if I compare this one to that one?
Yeah.
So could the numbers be found? Jonathan, here's the issue. You say, oh, Professor, I take each one of those numbers on top, put it over those numbers on the bottom, and then test and see what works. Corey, here's the problem. The kid didn't know. I wouldn't know until we start testing. He may say, oh, you mean 1 over 1? Yeah, that's a possibility. It just so happens if you test it, it's not gonna work. And 1 over 6? 1 over 6 is a possibility. Right answer. It just so happens if you test it, it's not gonna work. Negative 10 over 1? Possibility. Negative 10 over 6? Possibility. 2 over 2? Possibility. 2 over 3? Possibility. All these, you got to put each possibility. And then we have to test all those possibilities and find what worked. We lucked out here on one of these, off this right here. I don't have to test any negatives. Are there some negatives that would be possible here, even on the middle school problem?
Yeah.
In fact, the negative 2/3 came out. On this one that we lucked out, because Descartes' rule says don't test any negatives. There are no negative real zeros, so that helps a little. But wait till you see what's going to happen here. We've got to test some numbers here. Now let me pick up and ask you now, is there something called rational zeros theorem?
Yeah.
Ooh, read that to me. They have their handout. Read that to me, then I'm going to apply it.
So, R5 says rational zeros.
Now before you read it, there are 2 vocabulary words here. Rational, and what's the other one? Irrational. Can anyone tell me, they did not say irrational, here they said rational. Does anyone think they know what an irrational number is in the world?
Oh, it's a number that keeps repeating, so like pi, right? Or is that not an irrational number?
Okay, pi could be considered irrational because 3.14 and nothing.
It never
repeats.
stops,
It's-
right?
It never stops and there's no set
So like
number of digits repeating.
1/3 is also.
Okay, like 0.3, 0.333333, like 1/3, that's rational, because you have 3 repeating. If you have the thing going on forever, nothing repeats, not enough pair or there's a pattern there, it's irrational. Square root 2, irrational. Square root 4, rational. Okay, so those types of numbers. This applies only for well-behaved rational numbers. Okay, read that to me.
So, rational zeros theorem, it says let f be a polynomial function of degree 1 or higher of the form.
Hang on,
Yeah,
this one certainly is. Don't give me more.
would you like me to read the, a subscript n, or just?
No, no.
Okay, so not messing up, so, where each coefficient is an integer,
Okay.
and then it says.
My coefficients, should be a 1 here. I got 1, -7, 19, -37, 60, even my constant -36, are all those nice numbers, no fractions. And he's telling me, no fractions. They all have to be well behaved, they call them integers, okay, to the point. No fractions.
It says, if P over Q in lowest terms,
Oh, hold on. So he's describing this as P over Q, let's do we get back here, we go. So P over Q, that's what they chose to represent this as. Now, tell me what's going on, John.
it says if P over Q in lowest terms is a rational zero of F, then P must be a factor of a, what is that, subscript 0?
A subscript 0 is on the end. That's your constant term, like the middle school problem was -10. You have to list all the factors of the number on the end, constant called A subscript 0. You've got to list all the factors of that first on top. Guys, from the middle school problem, back to here, I've got to list all the factors of -36. That's my constant. His constant back there was -10. I'm gonna list all the factors with -36. Bear with me. Help me. Here we go. I'm gonna start out with 1 and -36. -1, +36. Is the professor, does this ever get any easier? Somewhat.
-312.
-3? Well, let me turn that around. +3, -12.
2 -18,
Oh,
-18,
geez.
2.
2, -18, hang on. -2, +18. More?
9, 4.
9 and 4.
9 and 9, -4.
9 and -4. Let me stretch this thing out. -9, +4. Am I leaving anything out?
-6.
Yes.
Oh,
+6.
Thank you. -6 times +6,
And the other way around.
and just turn around and do the same thing again. Okay. Woo, are those the factors of -36?
Yeah.
Overwhelmed, I'm with this one. Now, Jonathan,
Yeah.
the bottom part, they're called a Q. I now need to list the factors, now like the middle school did. List all the factors of that leading coefficient. Like we had a 6 here. So my leading coefficient on this problem is, if we lucked out, it's a 1. So the only factors of 1 are 1 times 1, oh, it's just a 1, -1 times -1. Those are the factors of my leading coefficient, 1. 1 times 1, -1 times -1. Here goes. Leo, you're gonna sort of help me out here. Can you tell me now at this point, we may not list all of them, but this is a problem. I should start out with the easier one. Not with this one. All right. Now I need to list something over something, something over something, something over something, and test what might work. That might be a 0. Now, you may start out with, Leo, back to you, may say, well, Professor, can I start at the very beginning and put 1 over 1? That might be an answer. I haven't found the answers yet. 1 over a negative 1?
No.
Of course you could. Negative 36 over 1, the top over the bottom. A negative 36 over a negative 1. Look at this. Supposed to do that for all of them. I've made a long problem here for my first example. Guys, look at all the possibilities here. Take each one of those numbers on top, over the one on the bottom, and that gives you a possibility. Let me just list a couple more. I got the 36s out of the way. Negative 3. Negative 3 over 1. Negative 3 over negative 1. I'm going to throw in one more. 12 over 1. 12 over negative 1. And others. You guys see how it's working? Now, here's the issue, big issue, big issue. When you finally see this on, not tomorrow's quiz, but on your next exam. Or no, we have a quiz next Wednesday. Could be that also. And all of a sudden, this happens every semester. I give it to the class. I say, find the zeros. And all of a sudden, you'll see some of your friends get up fairly early and leave. They've already found them. They're, just by luck, they went through and chose. They said, Professor, I see what you're doing, but could I jump down here and not, I don't necessarily say it's all these doing, Professor. That would take forever. Because this goes on and on and on and on. This would take forever. These are possibilities of zeros. I should put possible zeros here. These are not zeros. These are possible. We haven't tested yet. Possible zeros. Leo? No. You may jump around and some of your friends may be luckier than you are that day. And they may say, you know, Professor, it looks like maybe a negative 3. I don't know, I just have a feeling. Negative 3 is one of the zeros. And you test it, it works. And by the way, how many zeros am I expecting altogether? 5. Then you go back and test maybe positive 2. You were very lucky that day. Okay, like last time I was in Vegas, I won $8,000. $8,000. Very lucky. So you may try another number and it may work, and all of a sudden you're out of here. And others are saying, oh no, Professor, I didn't jump around. And none of those numbers were friendly to me. I just went from here to got this, and I tested this, and tested this. I've already tested 10 of these, Professor, and nothing worked. I've been all depressed, I'm crying. And finally, the numbers that did work are way down here on the end, and why do you tell me, sir, it's way down there? No, it's up to you as to what number you want to start out with. Okay, now, Johnson, I didn't list all of them. Now let me ask you, does anyone have a favorite coming out that you might say, Professor, it's just calling me that it works? That it is a zero of this crazy thing.
911.
Whoa, I'll tell you that large number 9 over 1, 9. I'm gonna tell you, just save us a little time here, Eric.
2 over 1.
Hang on, I did my homework. See, I'm doing my homework. Hang on. Make sure we got this. Fifth, hang on. Beautiful. Oh. Okay, 9 will not work.
Okay.
By the way, is 9 a possibility? Oh, it is. 9 over 1. Now, I'll shoot my looks and faces like, oh my goodness. Surely on an exam or a quiz, Professor, would not give me something that crazy as you on the board right now. No, I wouldn't. No, I would not give it that lengthy. But the process is going to be used on the one that will be giving you on a quiz or whatever, which will be much shorter. This one's crazy. Does anyone have a favorite number of all these coming out that you think, Professor, if I take it back, put it in here, plug it in like the middle school keep us doing, I'll get a 0.
What a negative two was?
It works.
Or negative two or negative?
Now, we've already said there are no negatives.
Oh, no negative reals.
Which helps in this case, that helps. Don't test one of those negatives. That just leaves the positives. So is it, positive 1 you want to test? Or is it 36 over 1? That's a positive, 36. 3 over 1, positive 3, we'll test 3. We're down to only the positives on this particular one. Does anyone have a favorite positive? I'll test it.
6.
Ooh, okay, that's very large. I'm not saying it wouldn't work. Leo?
3.
You think 3 works? Okay. Now, Leo. Now, I'm not saying Leo's right. I'm not saying 6 is incorrect. Leo, I'm good. But I don't think I want to do this. You got to put 3 in here, 3 to the 5th is 243. That's frightening already. You got to put 3 here, raise it to the 4th power, that's 81 times 7. You got to put a 3 in here, cube it, that's 27 times 19. You see what the trouble is? And if his 3 works, I'm supposed to crunch all that out and supposed to get a 0 for a result. After I crunch all this out. That would take forever. Wouldn't it? You agree? The 6 would be even worse.
Oh, could we use synthetic division?
Oh, hold on, I mentioned synthetic. I'm doing direct substitution. Can you imagine a 6? And by the way, Jonathan, I think 6 would be a possibility, right? Where is 6 up here on this?
At the end.
Oh, way down here, yeah, 6 over 1, that's a possibility. And can you imagine 6 raised to the 5th right there? As a student, stop me. 6 to the 5th. And then go to the next term, and hope, crunch it out. Nope. Now, thank goodness, mathematicians, which I love, have now come up with a quick way to do substitution. Not direct, it'll take forever. They call it synthetic substitution. Here's the way it works. We're going to test ours by synthetic substitution. Leo, I'm going to test 3, not by direct, by synthetic, and see if it works. All you need to do is block off on the side here the number that you intend to test. You want to test a 3. You're going to love this. Oh, this is great compared to direct. Then you go to this long out problem that Ramsey gave you today, and you look at all the coefficients and the constant, and you bring those numbers down over here. Jonathan, help me out. That coefficient, my leading coefficient was 1. What was next?
Negative 7.
Negative 7.
19.
19.
Negative 37.
Negative 37.
60.
60?
60, yeah.
Oh, okay.
And then, negative 36.
Whoa. And then negative 36?
Yep.
Jeez. Let me erase this, I got room here. You guys see what's going on here. Okay, negative 36 is next?
Yep.
Then?
That's it.
That's it.
Yep.
Here goes. Leo. I'm like you, I don't know, but here goes. Rather than direct substitution, and by the way, guys, I'll get the same answer as direct with, but short. It's called synthetic. Here's the way it works. After you list all your coefficients and the number you're testing, you always start with a 0 underneath the first number. And then add those up in that column. So 1 plus 0 gives me a 1. To see what goes underneath the next number, you multiply these two together. So 3 times 1 gives me a 3, that falls underneath the second number, add those up. That's a negative 4. To see what goes here underneath the third one in this synthetic, you multiply 3 times a negative 4. That gives me a negative 12. You got 7 now. To see what goes underneath the negative 37, 3 times 7, 21. Add them up, I think the negative, yeah, there's 16, is it? Okay. 3 times a negative 16, negative 48, that goes here. Add them up, I think you get, oops, 12. 3 times 12 is?
36.
Leo, I'm gonna ask you, how on earth did you come with, because 3 is working. 3 is one of the 5 zeros. Did you just guess?
Yeah, I kinda just did the tree back.
So you're one, oh, okay, whatever. But whatever, on that day of the quiz or whatever, Leo's gonna walk out of here. And you're gonna, I'll look at him, I'll look at him. Where are you going? I'm finished, Professor. You worked out the 5 zeros? I've had students every semester do that, somehow it just clicks, and they're very lucky, and click, 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 and they found it to work. We found that to work. Okay, beautiful. Now, how many zeros am I expecting? 5. We have 4 more. And none are negative thinkers. Now, does someone have maybe another positive 0 besides 3?
Positive 2.
You want test 2. Now, one nice thing about synthetic, after you find one that works, in other words, gives you 0 on the end. Can you imagine this, guys? He gave me a 3. I'm not gonna do it here. Can you imagine, Leo, if I should have taken it back here directly put it in, and patient, 3 to the 5th and all that business, guess what? I would get a 0. Guaranteed. If I do it directly through all this business, crunch all those big numbers out, they will all collapse into a 0. Leo says by synthetic, of course they will, Professor, will be 0. Okay, now, Eric, I'm gonna try, you want me to try what was, he said,
Positive
2? We're gonna try 2. Now, if you find one to work, there's a little salvation here. You get to line these up, and use the numbers that were left over from the one that worked. You don't have to go back to the beginning, unless you want to. That's after one works, only, and start the process again. Yes?
So you start, every time you start with 0. For syntax, so.
You mean right here?
No, the very beginning.
Oh, right here, beautiful, yes, always. Always, put 0 here, always. 1. Now, he wants me to test a 2. We'll test it. But you always get it. Always place a 0 for the first one. To see what's underneath that next number, -4, 2 times 1 gives me a 2. Let's get accustomed to that process. -2. 2 times a -2 is a -4. Gives me a 3. 2 times 3 is 6. Gives me a -10. 2 times a -10 is a -20. Eric, I think you're out of luck. Because I think this is a -8. No, unless I made a mistake.
That's what I got too when I did it.
And this is a -16, and when I add those up, I do not get that 0 I wanted. Oh, by the way, what would I get? -16? Guys, does someone follow me, is sure that -16?
Yeah.
Eric, I will tell the class, and you, which would be good, look at this. It didn't work, but it does say this. If I should now ask you to find, where is it? Over here. P of 2. Which usually tells us as a student, go through and replace all these x's by 2, Professor, and crunch it out. Guess what? I'm guaranteed that the answer is, even though it's not a 0, it's that remainder. If you go back and directly put a 2 in and crunch it out, you'll get -16. We could have been doing this all along in this class. When I asked you to find P of this, F of this, you could have done it by synthetic. You just look at the remainder and that's the answer. Without you plugging in and doing all the math. Eric?
Can you walk us through how you do the second one with the numbers that you got? I'm not quite understanding.
Oh, you mean right here?
Yeah.
Oh, okay, I
So you
started
started with 0 and 1.
I always start with 0.
And then you
You get a 1.
multiply.
Then you multiply these 2 together.
Okay.
That's how you get that.
Oh, and then you go from that. top
There,
number.
and then here,
Okay.
there.
Wait, but for the, excuse me, Professor.
Yeah.
For the first column, you started with 0, and how'd you get to 1 again?
I just added these up.
Oh, okay, got it.
They're stacked up,
Got it.
right?
Yeah.
It looks like, whoa, Professor, this is moving too fast. Okay, so that does not work. Now, at least it still tells me this, but it didn't work. Now, I'm gonna erase this anyone have another positive number that maybe will work, and I'll test it? Boy, Leo, you really got excited because you found 3. Does anyone have another number, maybe it will work?
4.
Wanna try 4? Here goes. Oh, by the way, is 4 a possibility? Where are my possibilities over here? Did I list them somewhere?
Yeah, it was,
I think I erased them. Was
Yeah,
4 a
they-
possibility?
it was a possibility.
P over Q, was it 4 over 1 somewhere in there?
Yeah.
Okay, here goes. It may work, Jonathan. It may work. I don't know myself. It'll work. Now check it. 0, 1, 4, 0, 0, 7, 28, maybe 16 and 28, guys, what is that, 12? I think. 4 times 12 is what, 48? Boy, I didn't make a mistake. And I got 60, if I made no mistake.
Doesn't work.
Didn't work. But, you know what this means. This means if you go back to that function, P of 4, guarantee you if you do it directly, you'll get 60. Guarantee you. So it's not much faster to find the, function value that I sent that. But it's not a 0. Guys, I need another one.
Positive 1, I already tried that.
Oh, I haven't tried positive 1 yet. Whoa, my time is running out. We'll get this done and we're finished. Okay, I'm trying, Eric, 1, 0, 1, 1, -3, -3, 4, 4, -12. Oh my goodness. It works. It works. Oh. About to run out of time. How many zeros am I expecting before I quit? 5. I've got 2. I know 2 of the 5. Let me just go ahead and do what I gotta do. Now, we can sit there, I can stand here, and we can test more. To see what's gonna happen. We can test more possibilities. Before I jump in and show you a little shortcut, which happens sometimes, does anyone have another favorite positive number you think would work? And I'll test it. Leo.
18?
Ooh, that's large, but we'll see. Now, if he wants me to test 18, here goes.
9 didn't work, right?
Always a 0 here. Not 1. Leo, 18 times 1, 18. We'll get some big numbers here. Ooh, 15. I'm getting scared. Because 18 times 15, I don't think it's gonna work. So if I see it ahead of time, I don't think it's gonna work.
One, two, three, four. 6.
I'm gonna try one more, then I'll show you the shortcut. 6. There's a possibility. Here goes. 0, 1, 6, 3. Oh, let me mess up. 18, not looking good. It's 22. Oh my goodness, I did make a mistake. It's not gonna work. You guys see ahead of time it's not gonna work? How many zeros are we missing?
3.
If this were a quiz problem, you walk out and you